All right, physical science. This is Coach Hicks. I know I don't sound like myself. I'm a little under the weather. But anyway, this is the end part of your Unit 5 notes. You need to watch this video and take your notes as you watch, complete them. You'll then use them to take a quiz and also prepare yourself for your exam, which is tomorrow. Make sure you got good notes. You have all the notes that you need. Anyway, without further ado, let's talk about, this is about chemical reactions. This is just a little shorthand version. Reactions. We're going to look at some types of chemical reactions, how we can slow or speed them up with rates, and then just a little bit about energy. So there's several different types of reactions. We're going to look at the four main types of reactions. So think about anything that causes a chemical change where we start with one or more compounds and we end with something different. Remember, that's what we were doing in balancing equations, was showing in a chemical reactions we still have the same amount of mass or the same amount of matter on one side in the reactants as we do in the products. So anyway, here's the different types of reactions. One of them is called the synthesis reaction. I am so sorry I sound so bad. Synthesis, sometimes you'll hear this called the combination reaction. This is where you combine two or more substances to form another type of substance. Just shorthanded, we see it written here. You have A substance and a B substance. Boom, we combine them into AB. A really good example of this is sodium chloride, table salt. We have Na, or sodium, as a solid, and then we have chlorine gas, Cl2. When combined, we end up with NaCl, which is table salt. So they're combined together. Sodium, chlorine equals NaCl, sodium chloride. We also got decomposition reaction. In a decomposition reaction, it's the right opposite of synthesis reaction. We have one substance that breaks down or decomposes into two or more simpler substances. So we start out with the AB, and then we go through the reaction, and we wind up with element A and element B, or compound A and compound B, a simpler substance. Excuse me. There's something called calcium carbonate, also known as limestone. You may have heard of calcium carbonate before. It's CaCO3, so it's actually made up of three different elements in this compound. Excuse me. When it's broken down or exposed to a high level of heat, it actually becomes something called lye. Lye is calcium oxide. Excuse me. It's CaO. So we start out with CaCO3, which is three elements. We end up with this compound made of three elements, and then we wind up with another compound, CaO, and then we also wind up with carbon dioxide gas. So that would be CO2. So it's not as simple as just saying we got a compound and now we got two elements. No, you start out with a much more complex substance, and it breaks down into two or more simpler substances, okay? We've got two other types of reactions. One's called a double displacement reaction. A double displacement reaction, I know this is the definition here, and you can read it. We're not diving that deep into it. Basically, you're going to swap out some of the ingredients, if you will, in the different compounds. Excuse me. So think about it here. If we had AB, which is made up of these two different elements, and then another compound made of CD, after the reaction, we'll see them start to swap partners here, right? Now we have AC and BD. There's several different things you could look at. A lot of things with metals. If you were to take magnesium, let's say, and put it inside a aqueous solution, that means one inside at water, with copper nitrate, the magnesium will jump over from originally to being with the nitrate. Okay, so the NO. It'd be easier if we were writing this on a board. Anyway, in the end, it would leave the let's see, the copper by itself, right? So they swap partners. It's a double swap. AB turns into AC, CD turns into BD. So you swap partners. A single displacement reaction, now notice this is OR, so it's kind of like just mark this through right now. A reaction, one element replaces another in a compound. So we go from having, excuse me, this is not written correctly right here at the beginning. Sorry, ignore this AB and then AC. It's actually, this one looks good. A plus BC equals AB plus C. You see the B swap partners here. Okay, sorry, I wrote this one wrong. This should have had a C right here, CB or BC. So anyway, it swap partners only once. Excuse me. Sorry, y'all. This is another way of breaking it down. I kind of like this one. That's why it's just the same thing over again, but it kind of gives you an idea of this stuff. So if we had one compound here and one compound here, and then boom, we have a conjunction of them. This is a synthetic or synthesis reaction. Decomposition, they were conjoined, they've broken down, they've decomposed. This oftentimes is in things like with heat or fire or explosions. A single replacement or single displacement is what we called it on our sheet. A was by itself, then in B and C were a compound together. Boom, now A and B have swapped positions, a single replacement and a double displacement reaction. You see they swap partners. In the beginning we had AB and CD. Now we have AD and CB, but this could have been A and C and D and B. Okay, but we have a double replacement. Excuse me. There's one little error on here. I'll tell you about it in a minute, but a lot of time chemical reactions involve energy being passed around in some way, or energy being presented in some way. An exothermic reaction, exo refers to exiting or leaving. This is a reaction in which energy is released in the form of heat. I'm not sure what I was going for here. Your notes have it wrong too. So in which energy is released in form, F-O-R-M, the form of heat. Heat exits the reaction, okay? It leaves the reaction. Like burning wood. The wood isn't just lit on fire and then burns up. We can feel heat leaving or exiting that reaction. Fireworks as well. Endothermic reactions. Endo means into. This is a reaction in which heat is absorbed or taken into the substances because of the reaction. You might have seen these ice packs before that are just, by themselves, but when you kind of crack them or you start moving them around in your hand, excuse me, they go from being this normal room temperature to being very ice cold. It's because the chemicals within it start to react with each other and absorbing that heat, taking it in. So it causes the feeling of it being cold on the outside. It's not so much, excuse me, making things cold, it's actually taking in the heat. Have you ever thought about this? There actually isn't anything like scientifically known as cold. Cold is simply the absence or the lessening of heat. Heat is in form of energy, thermal energy. There is no such thing as cold energy, right? So when the temperature reaches freezing, it's simply cold to us because of the absence of thermal energy. I always find that kind of interesting. When people start thinking about cold, there is no such thing much as cold. It's really just an absence of heat. I always think that's kind of interesting when you look at it scientifically. So anyway, endothermic reactions, heat is absorbed, oftentimes leaving things feeling somewhat cold. Sorry, y'all, my voice is just going in and out. I apologize for being so rough to listen to. When we look at a catalyst, this is something in a chemical reaction that we can implement that speeds up the chemical reaction or amplifies the chemical reaction without permanently being changed itself. Gosh, excuse me, y'all. Excuse me. A great example of a catalyst, sorry, my computer kind of glitched out there. in a catalytic converter. Sorry, still having troubles. There's a metal called platinum. Platinum actually doesn't permanently change itself, but it helps change carbon monoxide, which is completely toxic to us and a byproduct, excuse me, of burning fossil fuels. It helps change that into carbon dioxide, a completely harmless gas. So this platinum that's in these catalytic converters, it helps speed up that chemical reaction and move carbon monoxide into carbon dioxide without itself being permanently changed. Okay. The second thing, when it comes to how things can change in chemical reactions, is an inhibitor. This prevents or slows down a chemical reaction, or sometimes this just simply interferes with the catalyst to stop it. So these two things are very opposite of each other. A catalyst speeds up a chemical reaction, an inhibitor slows it down.